Barry Kavanaugh was a mechanical engineer and then has moved over to the software world. He comes to us from the MIT Lincoln Lab, which is a fantastic facility. I was up there for an XR and robotics thing, I think, a couple of years ago. It was absolutely fantastic. So I know his outfit does some really cool stuff. So please welcome to the stage, Barry Kavanaugh.
Great, yeah. Hello, everyone. So my name is Barry Kavanaugh. I'm an IT systems engineer at, is this the clicker? Fantastic. I'm an IT systems engineer at MIT Lincoln Laboratory, and today I'm going to present for you MITLL's Enterprise XR Journey. So just a little bit about MIT Lincoln Laboratory. So it's located in Lexington, Massachusetts on Hanscom Air Force Base. It has about 4,300 employees. Its budget varies from year to year between $1 billion and $1.5 billion. So the lab is separated into different divisions. They each have their niche. You can see the ovals, all the different areas of focus. Down in the lower right-hand corner is the engineering division. I'm a member of that division. So within the engineering division, there are a number of groups. The whole purpose of Division 7, the engineering division, is to exist as a central resource to provide design services to those niche divisions. So we've got a mechanical engineering group, fabrication group, and other groups, and they partner with those niche oval groups, divisions, to jointly develop often physical prototypes to prove out solutions to hard technical problems, in the name of addressing national defense concerns. So what I'm going to do is I'm just going to kind of blaze through the timeline just to give you an overall perspective on things, and then I'm going to dive deeper in the rest of the presentation in certain areas. So our journey began way back in 2016 when we obtained our first HoloLens 1 and mostly just experimented with it for a couple of years. And then ultimately, a couple of years later, we formed an XR team. I'm going to touch on that team a little bit more in a bit. And then around the time of COVID, a little bit before and then during COVID, we started to research applications to meet what we thought were some urgent needs. Both because of COVID and even before COVID, we had some ideas about XR, how XR could be deployed and helpful. And then later on after that, we deployed our first solution. This solution is meant to address design reviews, supporting the use case of design reviews. Then a couple months after that, we deployed a remote collaboration solution. And I'm going to talk more about that, and I'll have videos to show you on both of those solutions. So sometime after that, we had probably our first milestone, which is we had a high-profile use of the remote assist solution, where we had a whole bunch of technicians that need to be trained during COVID on how to perform composite part manufacturing, and the expert was located far away in the middle of the country, and we set up a remote assist session, a multiple-hour session, where the expert used a regular Teams client, and then back at the lab, the technicians were the HoloLens device, and they were able to receive real-time guidance from the expert. The expert could see what they were doing as they were trying to create these composite parts with their own hands and provide annotations spatially to give the guidance and the instruction that the technicians needed. Also, I'm going to be talking about probably what has really been our single most high-profile event, which was a couple of demonstrations and sessions with a sponsor where it involved a physical airplane. And then completely coincidentally, it turned out that here at the lab, we have, within our director's office, we have a technology office, and once a year, it identifies a technology where it wants to increase awareness throughout the lab. And last year, completely coincidentally, they chose the XR technologies. So they sponsored an event where a bunch of teams, half a dozen teams, 4 or 5 people each, came together, and they focused an effort over a couple of months to develop custom Unity applications to solve puzzles within a physical maze, and I've got a video on that. Now, despite all this work, we did find that at least one of our solutions kind of suffered a little bit from low adoption. So I'm going to talk a little bit about how we tried to address that, or how we're still working to address that. And then along the way, we felt that it was important to reduce the friction that the users experience when they're trying to use XR technologies. So we implemented a modest customization with our PLM system that lets people send data straight to PLM, from PLM to our XR system. Got a slide on that. And this is going to talk a little bit about, most recently we did some more demonstrations with our Air Force sponsors that involved showing how XR is part of the digital thread, and did the push with digital engineering. And we've got some material on that to show you. So this is going to be a video of talking a little bit about what we did with the airplane. And unfortunately, I can't show you the true mixed reality videos because the sponsor, unsurprisingly, won't release that. But what I've done here is kind of reenact what we did in mixed reality, but I did it in virtual reality. And also, we did use some of this virtual reality technology early on when we were coming up with the concept about how we were going to retrofit this airplane and fit all the testbed equipment into that confined space. So yeah, here's the video. I'm just going to talk through it. This is the Gulfstream 4 jet that the sponsor purchased. This is the 3D model of it. It's pretty accurate. And then initially, this is just the base model, although we did have to modify it for the sponsor, cut some holes in it. Okay, down at the back, you're going to see a pocket to the left. That's the bar that's present in this private jet. No longer in use, right? And then we did have to modify the plane on the outside as well. And then just using, in this case, virtual reality to lay out some concepts about how we're going to fit all this equipment in there. So we've got our mannequin model. We're just able to place it in one of the chairs that's already existing within the airplane, bring in the equipment cabinet. So it's pretty straightforward, pretty easy to do, not too challenging to get the models into the system. Just bringing the components in, then starting to review the ergonomics of things. And then this is a little bit later on when we added more equipment. And we've got our mannequin meant to mimic an actual use case where the operator is going to have to move back and forth among a couple different equipment racks. Check access and things like that. Okay, so a couple more videos here. This time we're showing mixed reality using the Theorem product, and then also a video on remote collaboration and some of its capabilities. And these are some short videos. These ones do have some audio to them.
The
Again, we
HoloLens
can't use
transforms
real
collaboration in the
models,
design
so
review
we've used
process
these
by
dummy,
enabling multiple individuals to
motorcycle
examine
models.
the same model simultaneously. The HoloLens empowers users to compare two designs side by side, fostering efficient decision-making and enhancing the overall design review process. This innovative tool facilitates seamless cooperation among team members, allowing them to manipulate the model in real time, isolate specific parts, delve into internal design components, and explore an exploded view of the system or focus on individual parts. Collaborators can also examine cross-sections, take precise measurements, and highlight components of interest. The HoloLens facilitates remote assist sessions, enhancing comprehension and efficiency in troubleshooting and training scenarios. Team members who are not physically together can still view and work on the same project. This capability fosters collaborative problem solving, enabling remote participants to actively contribute and interact with the shared content. Users can seamlessly share and annotate documents, drawings, and photos in real time. And overlay diagrams onto physical objects. The immersive nature of XR technology helps bridge the gap between individuals who are not physically together, enhancing communication and understanding.
So just to talk a little bit about how we're staffed, we have a small team. It's really made up of 4 people. There's one person that handles the information technology work, so that's me. So I'm there researching devices, procuring them, purchasing them, getting them on the network, dealing with the security, getting it implemented and running. And then we have 3 other technical staff members. They're the subject matter experts. They bring expertise in mechanical engineering, fabrication, and also assembly, integration, and test. You can see we're kind of pretty lightly staffed, right? I'm allocated about 20% or 1 day a week, and the rest of the 3 are a little bit less than that. So talking about a little bit more about the initial activities when we were first formed, and in the first year or 2 after, we deployed the first 2 products. So the Microsoft Remote Assist, you saw the video. The interesting thing about that, right, is that it is a true SaaS solution where we simply, pay for the licenses, write them a check. They send us back the 20 accounts that we're entitled to. We didn't have to install anything because it runs on Microsoft Azure GCC High Government Cloud. So it's a very rare thing, right? Currently being able to use a cloud solution like that, but that was something of significance. And then also, when it comes to selecting and deploying the design review tool, when you look out in the marketplace, there are several products out there that facilitate the idea of work instruction. But what we found was those are mostly focused on, if you already know what your fabrication steps are going to be, then you would get those products, use those products, whereas we're more in a discovery mode where we wanted to use the tool to discover and figure out what the steps were going to be. So we went with the Theorem product, which allowed for dynamic manipulation of the models in real time. So initial reaction to what we offered. So in regard to the remote assist in the first couple of years, during COVID, there was quite a bit of use. Some of the use cases involved our mechanical inspectors. They would use the remote assist product to call the design engineers and others and share with them how they were going to fixture the part to do the mechanical inspection, so they could have a discussion about whether they were measuring the features in the way that the design engineers wanted. Also, the assembly integration and test technicians, when they're trying to get these expensive, valuable prototypes hooked up into the various vacuum chambers and shaker tables and getting things set up and configured, they would use this as a way of showing the physical problem they were having with the prototype to people who were external, working from home. And then also we had a couple different situations where we had some newer technicians that would get trained on how to use clean room equipment. Also, some of the biological equipment. We had some technicians that would get training where the trainers would be at home, and then the newer employee would be at the lab wearing the device and streaming what their experience was. In regard to the design solution, the solution for design reviews with Theorem, the adoption was kind of low. Basically, to some extent, it was a situation of bad timing where a lot of our programs were already past the detail and conceptual and detail phase, and they were deep into the fabrication phase, and so mostly they were we kind of missed out on the window where they would adopt our technologies. And then also we did, frankly, do some outreach. We did some presentations. Our videos weren't nearly as slick as what you just saw in a relative sense. So we really didn't, it didn't really generate the evangelists and the advocates we were hoping for. People were impressed, but there really wasn't interest beyond that, not too much of it. Also, just frankly, Lincoln Laboratory is a hardcore research organization. The senior leadership likes things to happen from the bottom up rather than pushing things from the top down. And so our leadership was very supportive in providing the funding to buy the devices and to buy the software and implement it. But they didn't mandate that programs had to use it. So we do enjoy support, but it's not something that's going to be forced on the programs. So because of the adoption situation, we decided to kind of take a step back and try and reassess how we engage with the user community and further evangelize and convince people to consider the use of XR. So we went back to our design engineers, technicians, and we kind of did some detailed interviews and asked them about the pain points that they experience when they're doing their design work, and in particular when they're doing their fabrication work. And so we basically teased out the individual issues and opportunities they saw, and then we tried to match them with a long list of what we believed the strengths were and the individual features even within the Theorem software and with the remote assist. Also, we reached out to the wider community, so we joined a consortium, the area.org consortium we joined. I know some of you guys here are also members of that. And then also, we've had several visits here to Johns Hopkins, and we've learned a lot and benefited from those visits and those ongoing conversations, and certainly this conference here. And then also just tried to get educated on what was being said by the vendors and also in academia. So really, one of the things that we came across was this concept of the cognitive gap. This is something that our vendor, Theorem Solutions, talks about. And we also found an academic paper that kind of echoes what we saw there. And basically, the idea is that the XR technologies, what we're telling our users, is that the XR technologies allow you to accelerate your ability to absorb information that's put in front of you in terms of complex design challenges, because you can be immersed in your problem in mix of physical place or physical object with computer-generated content that you can't really do with any other technologies, including traditional 2D screens and CAD systems. So now when we re-engage with our users, we bring up more specific aspects of XR. We talk to them explicitly about the value of being immersed, whether it's in virtual reality or in mixed reality. We share with them the idea that you can truly see things at one-to-one scale. You don't have to, but if you want to see it at one-to-one scale with the devices on, you truly can see the entire size. You don't have to be guessing about looking at a monitor and trying to figure things out like that. And then because of the device's ability, it has spatial awareness. The devices can scan the room, generate a mesh, and understand your physical boundaries. It gives you an opportunity to, when you mix your computer-generated content with your real world, you can take advantage of collusion, and then when you're doing your design reviews, you can actually see where you've got conflicts, where you can fit things inside that airplane and where they're going to conflict with where the piping is and where the fuselage is and things like that. So just to talk a little bit about our inventory, over these several years. So we did get a couple of the HoloLens 1. Those just collect dust now because we moved on to the HoloLens 2. We've got about 17 of those. And then for virtual reality, we have a couple of the Vive Focus 3. Some of you guys may see those other devices down there. We did grab those, get one of those, and tried to make them work and tried to get use out of them. But this is something we don't really use anymore. And just in terms of how we handle the inventory, you know, with the HoloLens devices, we use something called provisioning packages. We haven't really invested with true mobile device management at this time because our inventory isn't quite large enough, and there's a lot of expense and overhead with that. So right now, that's the way that we do things. So this is just a little more information on the integration that we created. I would suggest that organizations that find themselves in the situation that we're in, you really would want to try and reduce the friction that your users experience. It's not too complicated to develop customization for your typical PDM and PLM systems to facilitate an ability to send data pretty easily. So this is just a screenshot of what we did with our ARIS PLM system, where the user would log into the ARIS PLM, navigate to the CAD item that they're interested in viewing in extended reality. They click on the Send to XR menu item, and then you know, the data gets sent and gets processed, and say, depending on the particular object that you send, 5 to 15 minutes later, they can put the device on virtual reality or the HoloLens for mixed reality and view the model. So just a little bit more about that Dynamics Remote Assist solution. This is just a picture from the vendor, Microsoft. This is basically how it works. And you can see those little green arrows. That's a situation where, you know, both parties, both the person that's using the device as well as the people that are remote, they can draw annotations so that, you know, the other party can see with a little more clarity about what people are talking about. And, you know, in order to do that, you need to take advantage of the unique capabilities of the device, which is the spatial awareness. These are just a couple other things we worked on that didn't quite pan out. VPN, so it turned out that the particular way that Lincoln Laboratory has implemented VPN with the Palo Alto Global Protect with two-factor authentication plus certificates, plus using the Prisma version of Global Protect, which is a government cloud version, it was going to be a big science project to get the lab's VPN configuration changed, and it wasn't justified to do it just for, you know, a dozen devices. So for the moment, we don't have VPN capability. The other product that we looked into, we did do a pilot, but our inspectors decided to not move forward with it because they didn't believe they would use it enough, was this product, Polyworks AR, which allows you to take like an Artec hand scanner and scan a mechanical part that had been machined. And then using the software, you can generate you know, a 3D model, color mapped 3D model. And with the device on, you can maneuver and overlay that 3D color mapped model on top of the physical part. And then it allows you to pretty quickly gain an awareness of what the true tolerancing is on that particular part that got fabricated. So next, I'm just going to talk really briefly and then show you a video. This is the lab-wide event that took place through the technology office to try and increase awareness of XR. I'm just going to show a video real quickly here. So kind of last effort to talk about is, again, we are mostly trying to do enterprise work, so we're not really, and we're looking to buy things off the shelf. But what we found, I think some organizations I've learned find that the off-the-shelf products maybe don't quite always meet the need. So we wanted to get a little better educated in what was involved in maybe creating our own enterprise applications. We've never really done this before. So we thought, okay, what would be an idea conceptually of something we'd like to try and mock up as almost a hello world application. And so the idea was to create what we'd call a stand-up design review application, a very simple situation where you would put a headset on someone, and then they would basically toggle through a list of 3D models, and one by one the team would have this design review. They'd look at the model, they could grab it, spin it around, talk about it, then push a button to extract data from our PLM system that you might want to know on when you're talking about the status of parts, and just toggle through everything and have this simple design review. And so this is something that we've been working on, again, just to kind of scratch the surface of customization. And these are the technologies that we find ourselves using. So, of course, Unity, and then at Lincoln Laboratory, we're using SolidWorks CAD. We ended up using the GLTF file format to bring the models in. We use the MRTK3 toolkit. And then, again, we use the Aris PLM system, so it exposes a web service that lets our Unity application talk to it and extract data. And so this is just a real simple video. I'm not going to show the whole thing, but this is the concept here that we created. So the idea is you push a button, it goes out to a web server, it gets a list of models, and then you can move the model around, take a look at it, talk about its status. Then you can toggle to the next model. You can get the PLM information, you push that button, then you move on to the next model. Taking a look at that, you're having your conversation. Okay, grab it. And then get its PLM information. That's basically it. So what did we learn, for just scratching the surface? There's really not a lot to say that's new that people don't already know from their just general custom application efforts versus off the shelf, where you can develop some really compelling, valuable point solutions to address very specific needs without having to go out and buy a much larger product and deal with the bloat and additional features that you don't want. Also, you can modify that product on your own schedule, assuming you have the resources, rather than having to deal with an enhancement request from a vendor, or spending more money with an outside consultant. But the challenges are that it does require high initial investment. You need to have some pretty skilled resources, and you need to stay on top of it to patch it when there's all kinds of vulnerabilities that get found, and other challenges and problems. Also, market uncertainty in terms of you got to be aware of the possibility that you'll be targeting a device and/or a toolkit or any of those technologies, the logos I showed, and then one or more of them kind of fall out of favor, go bankrupt, or just kind of languish. So it's something to be aware of. So overall, in summary, the XR team so far in the last several years, we've deployed 2 stable, what we call, our goal has been to make low-friction XR solutions to address the design review scenario and the remote assist use cases. At least in one case, adoption has been somewhat low. So we talked a little bit here about how we've tried to address that through sharpening our message and putting out some better communication and better multimedia to compel the user base to take further interest. We've had a couple of high-profile events, and they've all been successful, so we're really happy about that. The challenge has been that we just don't get a lot of at-bats so far, to use the baseball analogy. We've had a couple of opportunities. Those opportunities have gone well, but we're not getting a lot of at-bats currently. Okay. So just, in terms of overall XR, we find really, for our particular scenario at Lincoln Laboratory at least, the true mixed reality use case where you're blending together a real objects such as an airplane, along with the computer-generated content that you're creating, all the racks of equipment that need to go in an airplane, how you're going to lay it out. That is the single most compelling, most valuable use case where we really try and steer people towards, or we try and, those are the programs we try and support, because that's where you get the most value for the effort. Also, just talking about our future activities, you know, we're probably going to start to invest time in looking at some other devices. You know, you've got the Apple Vision Pro and the Meta devices. Also, we're probably going to be looking at some of those additional use cases that we haven't had a chance to look at yet. So, you know, such as IoT, so trying to stream and put into the field of view of the technician the information that's streaming from our test chambers and our shaker tables and all the other tests that are going on with physical prototypes. So rather than having to go back and forth into a control room. Also, you know, with some of the new devices and the really high resolution, you can have lots of different screens all projected in front of someone rather than having to literally set up all that equipment. Also, we'd be looking at applying XR to construction, because there's going to be a burst of building new facilities at Lincoln Laboratory. So maybe for architecture, the building information management models and things like that. Also, maybe experimenting a little more with some of the other organizations to support virtual reality and augmented reality experiences for lab tours, and just generally onboarding our employees, and maybe even for recruitment, because the devices are so much less expensive and a little more polished. We could potentially bring the lab to a recruiting event through the headset and show them some of our work to grow interest. And that's it with the presentation. So I really appreciate your time, and if anyone has any questions, I'm happy to hear them. I'm also going to be at one of the tables later, so the airplane experience, and then also that simple custom application will be available to demo. Okay.
Hi, Barry.
Hi.
I know we've talked about this before, but I'm going to throw it out anyway, because I think it's a topic all of us should be thinking about. I was on that call with you about VPN hassles and the HoloLens, and I note that's kind of an underlying theme and several frustrations of the security aspects of some of these devices. Do you have thoughts about where we're heading in the future? For example, if MIT's lab can't re-architect to better handle devices like this, where does the future of some of the security concerns with all of our devices lie? Here, I've been able to get VPN to work, but boy, I feel like I'm on the barest edge of keeping it consistent and knowing that some change in the future won't throw me on the outside of the network again. So any thoughts you have there would be appreciated.
Yeah, you know, there's two things that come to mind. We're pretty optimistic that we can get the Apple Vision Pro to work on VPN, because there's more interest in that device within the lab, at least at the moment, because it's getting a lot of publicity, and also the lab has more resource dedicated to that. Also, the lab uses the iPhone as the official phone, and so we've got like over 1,000 of them, and they have a dedicated resource that spends a lot of time understanding all about the Apple product lines and trying to get them to work on VPN, because we run VPN on our phones. So I think, you know, more specifically, we're optimistic that maybe we can get VPN to work once we adopt that device, although there'll be challenges, other challenges with that device. You know, I think in terms of the larger matter, we've had some discussions with our IT department, and they're asking us, you know, maybe you don't even really need to use VPN. Maybe you can actually go straight up to the particular resources on government clouds, as long as you kind of restrict the device's access and put additional mitigations in place. So that's what I'm thinking about that situation. Hi.
Hey, Manuel Reber from the George Washington University. I have a question regarding your XR, remote XR project, and there you talked a little bit about the evaluation. I was wondering like if you could elaborate a little bit further into like how exactly you researched there, like how you evaluated and how the study was designed, and also a little bit, you mentioned cognitive load, just wondering if did any evaluations on that as well.
So were you asking about the remote, the remote solution? What was the question about?
The evaluation there, basically the feedback you got, yeah, a little bit further onto that.
Yeah, I think the thing about that solution was really attractive was we needed to get something implemented fast because of COVID. And it was just, everything kind of aligned nicely in that product is, again, a rare situation. And maybe back to Phil's question, you know, that product is available, a very rare situation where it is a SaaS product that runs on a government cloud. And so we were able to get that up and running very, very quickly and exploit the fact that it runs on Azure GCC High. So it met all the security requirements because it was already blessed by the central organization. You know, I think we didn't really do a whole much more in terms of research about cognitive load other than basically what the supplier in the paper said, which was something also that became readily apparent to us when we put the device on and we're immersed in the actual 3D space, and we can, you know, it's literally we can point out and show very quickly to the users what the value is in terms of seeing the geometry and the conflicts.
All right. Thank you very much.
All right.
Once again, Barry Kavanaugh, everyone.
Thank you.